If you are lucky, you might be given lines on a graph that already have points identified. And if that's the case, you can pick any 2 points in order to find your slope. However, that's not the case every time. So this will be about picking, not your nose, but picking points. All right, so the trick here is that you want to find points on the line where they cross perfectly. All right, so this first line here is an example of a lot of points that don't cross perfectly. You can in fact see that the y-intercept is somewhere between 1 and 2 and closer to 1. So that's not a point that you're going to want to use to start with. But then if you go over a little more, you can see that it hits that intersection really nicely right there. That would be a good point to use. All right, as I continue over, I still see this is between 2 and 3. So I don't want to use that one. I'm going to continue next between 3 and 4. I don't want to use it. Continuing, it's getting closer to 4, but it's not quite there yet. Then when I get to this point here, it's perfectly on that intersection. So that will be my second point. And now I can easily do rise over run, in which I have whole numbers, +3 and +4. Okay? This can even happen if your line is decreasing. So you can see here, on this one, we are lucky enough to see that the y-axis the line crosses the y-axis, has a y-intercept of +2. When I continue down, it crosses the x-axis at a perfect number as well. And it's in the middle here, but when I get to this point, all of these points, because they meet at a perfect intersection, would be good. Okay, now sometimes the graph will look a little different. Here we have a graph that looks a little bit different than the other square grid that we've been using because of the spacing here. So again, we're lucky enough to have a perfect y-intercept there. That's a nice point. And it kind of is running in between, but does then, when I get to my next line on the x-axis, fits really nicely in there for all of these. You do not want to use this point because that point doesn't line up really well here. We'd have to estimate how far between 10 and 15 this point is, and that's not what we want to do. We want to try and be as accurate as possible. Okay, and I have one more here for us as well, and you can see here, again, we got lucky with the y-axis, so we'll pick that point first. That's always where I like to check first. If I go backwards, this is kind of in between, so we don't want to go there. We go to the next one, that's kind of in between. I don't want to go there either, but when I go to the next one, that looks like it hits at a perfect point. So I continue that pattern. In between. Oh, that might not be a perfect point. Oh, this is a tough one. Ooh, this one looks nice though. So I don't like this point anymore. I would think about using some extreme points if it's very close, and checking to make sure this pattern exists with the rest of your line. If you're unsure, this is a tough one because when I tried to repeat the pattern, it didn't maybe quite work out as nicely. 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Definitely doesn't work out as nicely. So maybe using extreme points in that scenario, not going in between, checking your y-intercept and x-intercept first. It won't always work. Like for over here, doesn't fit nicely. So find points that meet exactly at an intersection and are on the line.